Doing something like this is pretty common on the AP exam, saying find the first four non-zero terms of a Taylor series around x equals 0. So this is actually a Maclaurin series because it's about x equals 0. So let's start with just sine. Sine of x, that Maclaurin series, is x minus x cubed over 3 factorial plus x to the 5th over 5 factorial minus x to the 7th over 7 factorial, like that. Maybe I'll do one more. Okay? So that's our Maclaurin series. That's the series about x equals 0. So looking at this says we'll do sine of x squared. Well, using what we've done previously where we can substitute in, let's do sine of x squared. I'm going to put the approximate there, so x squared minus x squared cubed. Instead of 3 factorial, I'm going to write 6. X squared to the 5th over 120. Seven factorial is 5,040. That. So then it says that we should take this series and we should subtract x to the 4th from it and then divide it all by x. So I'm going to do that. I'm going to say, well, I'm going to have x squared minus x to the 6th over 6 plus x to the 10th over 120 minus x to the 14th over 5,040. And it had said only 4 terms, so I'm going to stop there. I don't think I need more terms. And then I'm going to subtract out x to the 4th and divide everything by x. So take a look at what I've done here. I've basically done a substitution. I've said, well, I don't necessarily know what the sine of x squared is, but I know that it's approximately this thing in blue right here. So I just substituted in place, and then I subtracted x to the 4th and divided by x. So let's kind of order these a little bit. Let's say, all right, x squared divided by x is just x. X to the 6th over 6 divided by x is x to the 5th over 6. X to the 10th over 120 over x is x to the 9th over 120. X to the 14th would be x to the 13th. And x to the 4th, so this is x cubed. Now usually when they say first 4 terms, they want them starting with the lowest power and working up. So our lowest power would be this term, so let's write that to be just x. Our next would be negative x cubed. Our next would be negative x to the 5th over 6. And our next would be positive x to the 9th over 120. These are our first 4 terms. And real quickly, I just wanted to show you how this worked, okay? So in red, I have graphed the original function, sine of x squared minus x to the 4th over x. And in blue, I have graphed the series we found, the Taylor series about x equals 0. And I just want you to see, we started it at 0, but look at how wonderful a fit it is, maybe until positive and negative 1.5. And then after that, of course, we would need to add more terms, maybe a 5th or 6th or 7th term to get a better fit. But look at what a wonderful fit it is for a period of time around about x equals 0. And of course, we designed it to be perfect right here, but as it moves away, it's still pretty good for at least plus or minus 1, and maybe even a little bit further. Okay, so we can do a lot of things with the few series that we have to memorize. We can do a lot of adjustments and make polynomials that are easy to work with. Look at this function and think about if you were asked to integrate this. And I said, find the area from 0 to 1 of this function. If I said that, I said, okay, integrate that. From 0 to 1. You would have no idea how to do it. You would have no idea how to integrate that. But integrating something that's almost the same and is only a polynomial, this would be really, really easy to integrate. Even though we wouldn't know how to do this one, we would know how to do that one in blue very quickly and easily. And that's the point of Taylor's series.